Students, my voice is audible. The screen is visible. Anyone?
Yes, sir.
Okay. Okay. So good morning to all. And today we are going to see uh, lecture number 27, equivalent circuit of single phase induction motor and problems. The equivalent circuit, it will take more. The equivalent circuit will take more time to explain, so I have recorded the video. That video I will share it now. Okay, now we are going to solve the problem. Once the problem have completed, then I will take the equivalent circuit. This is the problem. A 250 watt 230 volt 50 hertz single phase induction motor used in fan and conveyors has the following constants for main and auxiliary winding. Main winding having 4.5 plus J 3.7 ohms. Auxiliary winding will be ZA 9.5 plus J 3.5 ohms. Determine the value of the capacitor that will place the main and auxiliary winding current in quadrature at starting. Can anyone tell me what type of motor it is? Anyway, it is single phase induction motor. Now, what is the type of motor? What is the type of motor? Can you please justify? Because I have given application. It is used in fan and conveyors. Can you please tell me what is the type of the motor? Identify the type of the motor.
Capacitor start.
Yeah, good. It is capacitor start induction motor. Okay, induction motor. Now we know the capacitor start induction motor diagram. Okay, the circuit diagram. Plus minus V you are applying. It is having it is having a two winding. One winding will be it will be main winding. Okay, it will be main winding. Another winding will be connected in parallel. That winding called auxiliary winding. What is another name of auxiliary winding? It is starting winding.
Starting winding.
Good, starting winding, and it's having a capacitor. Okay, connected capacitor, and it's having a switch. What is a switch? It is centrifugal switch will be connected. The current flows in main winding is nothing but Im. The current flows in auxiliary winding, it is Ia, or we can say it will be IST also. Okay, IST, whether we can say it is Ia auxiliary winding, or it will be starting winding also, starting current IST. Both notations you can use. Okay, here the capacitor symbol here it we are mentioning C. Okay, so inside there will be a rotor is there. The rotor is having the slot. Is having the slot. Okay, this is the rotor. Or understand? This is the input current I. Okay, so this is my junction. Now this diagram I already explained the concept. Okay, the concept is very simple. When the switch is closed, at that time the auxiliary winding will charge the capacitor, and this capacitor will make the motor to start. Okay, so once a motor will achieve the synchronous speed, then immediately the centrifugal switch will be open, the auxiliary winding will be disconnected. So by using main winding only, we have to make the motor to run continuously. So auxiliary winding will be applicable only for initial, just for some 2 seconds or 3 seconds, okay, or 5 minutes, and afterwards we have to remove the auxiliary winding and we have to find out the operate the motor by using main winding only. And you know, the winding means this is the winding, okay, this is the winding. The winding carries both resistor and reactor. Understood? Understood or not? Winding call it as it is having a combination of resistance and reactance. This is R, this is X. Okay, so the combination of resistor and reactance we have to say Z. Z equal to R plus JX. Understand or not? Okay. Understand? The winding call it as it is a combination of resistance and reactance. So the impedance we have to mark Z equal to R plus JX. Now by using this concept, I am going to write a given data. Given data. So how many windings are there? We have identified a capacitor start induction motor. There are 2 windings are available. One is main, another one is auxiliary. For main winding, the impedance value Zm equal to 4.5. It is in given data 4.5 plus J 3.7 ohm. Okay, J 3.7 ohm. Okay, this call it as this 4.5 is the resistance term. R M plus J. This 3.7 will be a reactance term. X M ohms. Are you understand? Okay. Now in the given data, Zm will be represented in rectangular form. Okay, rectangular means real and imaginary form. And how to convert it into polar? How to convert it into polar? Anyone knows? How to convert into polar? You know that? Anyone knows? How to convert it into polar? In polar form, the value will be, you have to press, it will be a polar, POL option will be available in your calculator. If you convert it into polar, the value will becomes around 5.8258 angle 39.42 degree. Okay, you see here, again I am getting into the screen. Whether my video is visible now? You are seeing my calculator, students? You are able?
Yes, sir.
Okay. This is the FX991 calculator. First you press the on button. Okay. Then you have to press shift polar. Okay. You have to press shift and polar, POL option, which is available in downward, POL option. Okay. If you press polar, here it will be called it as POL within a bracket. Okay. That there you have to type 4.5 comma 3.7 and close the bracket. Okay, once you type the datas, then you press equivalent button, this equal symbol. If you press, you will get how much value you will get it, 5.825. okay, this value you are getting. Okay, this is my magnitude. Okay, in polar. Then you have to find angle. Then you have to press recall F. Recall F. Okay, recall F, RCL, and press F button. If you press F button, you will get an angle 39.42 degree. Are you understand? Please, anyone, can you please give the answer? Are you understand or not? This is the method to calculate the parameter from rectangular to polar. Are you understand? Anyone?
No, sir.
No, sir. Ashwana, just now you enter into my class. Shushma,
Sir? Sir?
are you understand this? How to convert into rectangular to polar?
Yes, sir.
Okay, thank you. Okay, now come to this. Okay, this is this is the z term value. Okay, like that we have to calculate for za. Okay, za call it as auxiliary winding. Za equal to, it is 9.5 plus j 3.5 ohms, 3.5 ohms, which is equal to, okay, which is equal to, now here you see, or this is RA plus JXC, and this auxiliary winding is connected with the capacitor, right? Okay, it is connected with the capacitor. So JXC, okay, JXC we have to mark plus JXC, this is 3.5, it is additional value, and we have to mark minus JX, this minus JX for capacitor. Okay, minus Jx for, because capacitor is a parameter which having leading power factor. Okay, it is having a reactance, so minus Jx. So I can write 9.5 plus J 3.5 minus Jx. Okay, minus Jx I can write it. This xc call it as 3.5 ma, and this minus jxc means it is a capacitor value. Okay, reactance value. So minus jx, minus jx. Okay, now as per your problem, it is a capacitor start induction motor. Normally the main winding current lags behind V by, it is 39.42 degree. This is the voltage IA, this is IM. Okay, so this angle will be lagging 39.42 degree, and you will get a overall current. Okay, so what is the angle between IA to IM means it is 90 degree. Okay, it is 90 degree. So therefore the phase angle time phase angle between IM and IA is 90 degree. Okay, therefore we have to find this phi a value. We have to, because we don't know the phi a, so phi a equal to, overall angle is 90 minus your IM. How much your IM angle? It is 39.42. It degree, which you are getting, it is 50.58 degree, 50.58 degrees. Okay, then till now you have any doubts? Have any doubts, students? You have doubts? Anyone? Anirudh? Harish? Harisha?
No, sir.
Okay. So now by using a right angle triangle of my impedance, okay, the right angle triangle of impedance is the right angle triangle. This is phi, impedance Z, resistance and reactance Ra, Xa, then Za. This is a right angle triangle of impedance. Right angle. So by using right angle triangle, we have to write tan, because we don't know the phi a value, right? So tan phi a, because we don't know the reactance, x term we don't know the reactance, so tan phi a equal to, because we don't know the reactance parameter for capacitor, so tan phi a equal to, what is tan theta, trigonometric ratio, what is the tan theta formula? Anyone? Opposite by adjacent. So opposite will be x divided by adjacent will be RA. Okay, RA. So x term we don't know, because the x call it as the reactance parameter, the combination of reactance parameter with auxiliary winding and capacitor. Okay, divided by RA. How much? As per your problem, it is, this is RA 9.5. 9.5. Therefore, tan, how much for phi a we already calculated. Substitute 50.58 equal to x divided by 9.5. X divided by 9.5. So therefore, x equal to 9.5 into tan 50.58 degree. So we'll get 11.5572 ohms. This is my x. Okay. Now we already have the formula. It is already written. Okay. Here you see. Here. Okay, this term, okay, 9.5 plus j, 3.5 minus jx. So by using this term we can write xc minus 3.5, which is equal to x. How I am writing means, it is 3.5 minus x equal to xc. Therefore xc minus 3.5 equal to x. Okay, this have calculated from this equation. This you can mark it as equation 1. Okay, so from equation 1 we are considering only the reactance term. So from this, xc equal to x minus x plus 3.5. X plus 3.5. So how much X value? 11.5572 plus 3.5. Therefore, Xc we are getting 15.0572 ohms. 15.0572 ohms. Okay. Now, this Xc called it as capacitive reactance. Till now we are not calculated the capacitance value. Capacitive reactance. This is my capacitive reactance. Okay. Now we know the basic equation of capacitive reactance. We know basic formula for capacitive reactance. What is the formula for capacitive reactance? Xc equal to 1 by omega c, where omega is the angular frequency. Okay, where omega is angular frequency. Angular frequency, omega equal to 2 pi into f. Yes, f stands for supply frequency. So this value substitute here. 1 by 2 pi fs into c. Okay, into c, which is equal to 1 by, this formula you can reverse it. Therefore, c equal to 1 by 2 pi fs into xc. Okay, now substitute. 1 by 2 pi into how much fs? As per our problem, it is 50 hertz, which is in given data. 50 into xc value is already calculated. 15.0572. Okay, how much? What is the answer? Can anyone tell me? C value how much? C value. Students, please give the reply. What is the C value? C value. Anyone? Grishma? Sartak Das?
Sir, is it
2 point?
2.11 into 10 power minus 4?
2.1140 into 10 power minus 4 farad. Okay, normally the capacitors will be mentioned in microfarads. So please press in calculator, press ENG button. If you press ENG button, we will get the answer. C equal to 211.40 into 10 power minus 6 farad. That is C equal to 211.40 microfarad. Okay, this is the answer. Okay, this is the method to calculate the capacitor, which will be used in fans and conveyors. Any doubts? Any doubts? This is one important problem in your internals and assignments also. Just I will change the parameters in the question. Any doubts? Can you please give reply? Anyone?
No, sir.
Okay. Now I am going to solve another problem. Okay. You see this problem. Please write the problem. This is, there will be a main and auxiliary winding impedance value of 50 Hz. Capacitor start single phase induction motor used in residential air conditioning compressors, that is ACs, which we are using in our houses, or 3.J 2.7 and 7 plus J3 ohms respectively. Now you have to calculate the capacitor since both the windings are connected in series to achieve a phase difference of 90 degree at starting. Okay, first write a given data. Given data. Fs, how much Fs? It is 50 Hz. 50 Hz. Then Zm. Zm equal to main winding. 3 plus J 2.7 ohms. This call it as Rm plus Jxm ohms. Okay, now what is the answer? Now it is in rectangular, right? Please convert it into polar and give me the answer. Zm how much? Can anyone? Zm value, please give reply. Please give the answer, ma.
4.036
4.036
at an angle 41.98.
41.98. Good. 41.98 degree ohms. Okay, this is Zeta. Now, in the same manner, we have to calculate Za also. Za equal to 7 plus J3. What have to mention? You have to put minus Jx, because since the auxiliary winding will be connected with capacitor. This is main winding, this is auxiliary winding, this is capacitor. Okay, capacitor is having Jx. Okay, so minus plus J3 minus Jx. Okay, so this you have to write 7 minus Jx, since J3 minus Jx, we have to write minus J3 minus J3, yeah, Jxc. Okay, 7 minus Jx. Okay, now what is the angle of Im and Ia? How much angle it is? How much angle they are mentioning? It is 90 degree, right, as per your question. So therefore phi A equal to 90 degree minus your Im. How much your Im angle? 41.98. Because we know this is V, this is Ia, the angle is phi A. is IM I. The angle between IM to V, it is phi M. Okay. So phi A equal to, you have to take overall angle is 90 degree. Overall angle will be 90 degree minus 41.98. How much? Anyone? 48.02. 0 degree. Okay. Then what is the next step? You have to calculate the reactance term. So by using right angle triangle, this is phi A, ZA, this one will be RA, this is reactance. So by using this right angle triangle, we have to write tan phi A. Tan phi A equal to opposite by adjacent. Opposite will be X, adjacent will be RA. Therefore, X equal to RA into tan phi A. Now here we have to substitute all these parameters. How much RA? What is RA? As per your given data, RA ZA equal to RA plus JX. Okay, it is RA will be 7. 7 into tan phi A, it's already there, 48.02 degree. 48.02 degree. So how much more? Can anyone? Therefore x equal to
7.780.
7 point, I got 7.779. 7.7
I got 78, sir.
78. Okay, fine. Because you have rounded to 8. Okay, but I have put whatever I got it, I just put 7.78 or 7.779. This is the reactance term. Okay, now you have to find out the XC. Okay, XC equal to, we already know from equation 1. Okay, this you mark it as, this above parameter you mark it as equation 1. Okay, so from equation 1 we can able to write the reactance term. We have to consider only reactance. Consider reactance only. Okay, so what is my reactance term? So the reactance term will be 3.5 minus JXC equal to X. Okay, I'm just eliminating the J terms. Okay, I'm just taking 3.5 minus JXC equal to X. Therefore, XC equal to X minus 3.5. That's right. So XC, how much value it is there in your problem? XC, not 3.5. Sorry, it is I'm doing something. How much XC, ma? What is the value there? It is 3, right? Three minus XC equal to X. Yeah. So therefore XC equal to X equal to X equal to you got 3 plus X, sorry, yeah, 3 minus XC equal to minus X. So therefore XC equal to X plus 3. So how much X value? X value how much? 7.779 plus 3. You got 10.779 ohms. Okay, so therefore we know the basic equation xc equal to 1 by omega c. That is 1 by omega is 2 pi fs into c. Therefore c equal to 1 by 2 pi fs into xc. So now substitute 1 divided by 2 pi. How much our frequency in your question? It is 50. 50 into xc. How much you got it? Xc 10.779. Now can you please tell me the answer? Anyone? Anyone? Can you please give the answer? C value? C value?
295.305
Yeah,
microfarad.
295.305 microfarad. Good. Okay, this is the answer. Have any doubts? You have any doubts, students?